The universe may be filled with mirror particles, and these otherwise undetectable particles could be shrinking the densest stars in the universe, turning them into black holes, a new study suggests. These hypothetical evil twins of ordinary particles would experience a flipped version of the laws of physics, as if the rules that govern known particles were reflected in a looking glass. According to a new study published in December 2020 in the preprint database arXiv but not yet peer-reviewed, if these particles exist, they would be shrinking the densest stars in the universe into black holes. Today we will discuss with you about the strangest thing in the universe that crushes all the planets into black holes. Welcome back to Signature's Life, and you're watching Signature's Science. Several fundamental symmetries in nature give rise to the laws of physics. For example, the ability to move an experiment or interaction in space and have the same outcome leads to conservation of momentum. But one of these symmetries, the symmetry of reflection, isn't always obeyed. The symmetry of reflection is when you look at the mirror image of a physical reaction. In almost all cases, you get the exact same result. For example, if you toss a ball up in the air and catch it, it looks exactly the same in the mirror. The gravity respects a reflection symmetry. But not all forces play along. The violator of reflection symmetry is the weak nuclear force. Whenever the weak force is involved in some particle interaction, the mirror image of that interaction will look different. The classic experiment that first detected this effect found that when a radioactive version of cobalt decays, the electron it emits prefers to go in one direction, rather than any random direction. If the weak nuclear force obeyed reflection symmetry, then those electrons shouldn't have known which direction is which and popped out anywhere they please. Physicists have no idea why the mirror symmetry is broken in our universe, so some have proposed a radical explanation. Maybe it's not broken at all, and we are just looking at the universe the wrong way. You can rescue mirror symmetry if you allow for the existence of some extra particles, and by some, I mean a lot. A mirror image copy of every single particle. There would be mirror electrons, mirror neutrons, mirror photons, mirror C bosons. You name it, it's got a mirror. Other names for mirror matter include shadow matter and Alice matter. By introducing mirror matter, reflection is preserved in the universe. Ordinary matter performs left-handed interactions, and mirror matter performs right-handed interactions. Everything syncs up at the mathematical level. But how can scientists test this radical idea? Because the only force that violates mirror symmetry is the weak nuclear force. That's the only force that can provide a channel for regular matter to communicate with its mirror counterparts, and the weak force is really weak. So even if the universe were flooded with mirror particles, they would be barely detectable. Many experiments have focused on neutral particles like neutrons because they don't have electromagnetic interactions, thereby making the experiments easier. Searchers for mirror neutrons haven't turned up anything yet, but all hope is not lost. That's because those experiments have taken place on Earth, which doesn't have a super strong gravitational field. But theoretical physicists predict a very strong gravitational field can enhance the connection between neutrons and mirror neutrons. Thankfully, nature has already crafted a far superior experimental device to hunt for mirror matter: neutron stars. Neutron stars are the leftover cores of giant stars. They are extraordinarily dense. A single teaspoon of neutron star material would outweigh the Great Pyramids, and extremely small. Imagine cramming 10 suns worth of material into a volume no bigger than Manhattan. Neutron stars are essentially city-sized atomic nuclei composed of individual neutrons crammed together just about as tightly as possible. Neutron stars can hold themselves up from the crushing weight of their own gravity by a quantum mechanical process called degeneracy pressure. But that pressure has a limit, and with fewer regular neutrons, that limit shrinks. If a star had a ratio of 1:1 of ordinary neutrons to mirror neutrons, the maximum mass of neutron stars in the universe would be about 30% less massive than what we would normally expect. More massive than this, and neutron stars would collapse into black holes. Scientists have observed neutron stars bigger than this, which at first glance might mean that mirror matter is a dead and idea, but the case isn't closed. The universe is only so old, that is 13.8 billion years, and we have no idea how long this changeover process can take. It's possible there just hasn't been enough time for the neutron stars to make the switch. The cool thing about neutron stars is that scientists are looking at them all the time. By finding and observing more neutron stars, they might just find a sign in any of those signals that there is a hidden mirror, and dare I say evil, sector of the universe.